What if your neural network was solving a physics problem in the wrong universe? That sounds abstract, but it's exactly what this paper is about. And fixing it cuts error in half with 6 times fewer parameters. So these are the Maxwell equations, and they govern all of electromagnetism. 4 equations: electric fields, magnetic fields, and how they propagate through space and time. So physicists have known for over a century that these 4 equations collapse into one if you write them in right mathematical language, spacetime algebra or STA. The key object is something called the Faraday bivector. Instead of treating electric and magnetic fields as separate things, STA fuses them into a single geometric object that lives naturally in 4-dimensional spacetime. And this gives us a single equation, as you can see here, and done. Most neural networks solving Maxwell's equations ignore this. They work in ordinary 3D Euclidean space, treating the electric field E and the magnetic field B as separate components, which is mathematically valid but physically awkward. It's like solving a problem about circles using only square coordinates. So here's the core intuition. When you embed your data into a mathematical space, the structure of that space becomes an inductive bias for your network. If the geometry of the space matches the geometry of the physics, the network has a much easier job. It doesn't have to learn structure that the algebra already provides for free. Otherwise, the model must use data to learn that structure itself. So Clifford algebra networks, also called geometric algebra networks, already exploit this idea. So before moving into them, so think of the convolutional neural networks. They have this 2D localized inductive bias. So that means that structure of the image is being embedded into the architecture itself. So no need to learn that explicitly using data. That is the same idea we are using here, but instead of convolutions, here we are using Clifford-ResNet, and the Clifford algebra is being embedded into the network architecture. And they operate on multivectors instead of plain tensors, letting the algebra encode geometric relationships directly. But the choice of which algebra still matters enormously. The Clifford-ResNet baseline embeds Maxwell fields in 3-dimensional Euclidean space. E is a vector and B is a bivector. They are different grades packed into one mixed multivector. The geometry is right locally, but the algebra doesn't know about time, and it doesn't know that E and B are fundamentally the same object viewed from different reference frames. STAResNet embed everything in space-time. And now both E and B are bivectors of the same grade unified in the Faraday bivector. The algebra respects Lorentz symmetry. The network operates in the natural home of electromagnetism.